SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering, and today we shall discuss about the operation of the Cochran boiler. So, you know that if we recall, in the last class we have discussed about the Babcock-Wilcox boiler. We have seen the working principle of the Babcock-Wilcox boiler. We have also seen the cycles, there are different cycles of two streams, and finally you have discussed about the objectives, rather functionalities of the components which are there in the Babcock-Wilcox boiler. So, today before going to discuss about several other issues related to the operation of boiler, let us first discuss about the Cochran boiler. So, you know, I am not going to discuss again, because we have discussed the importance of boiler in the steam power plant. We all know that this is the device which is used to produce steam, and while steam is getting produced in the boiler, we need to supply heat either by burning coal or other fuels. So, Babcock-Wilcox boiler is a, what I have discussed, is a water tube boiler, you know, because water is allowed to pass through the tube and the flue gas, the product of, rather high temperature products of combustion, you know, flow through the cell. But this is the boiler which is called as the fire tube boiler. So, Cochran boiler is a fire tube boiler. So, from the name itself we can understand the fire tube. So, the hot flue gas will pass through the tube, while water will be allowed to pass through the cell, and when these two different streams are allowed to pass, they will exchange heat and water will be converted into steam upon taking heat from the high temperature products of the combustion, that is the flue gas. So, similar to what we have done in the previous class, let us first identify the flow direction of both water stream and the flue gas stream. So, there are several components. I have tried to label those components in the boiler itself. Also, I have listed down their name. So, the name of the components. So, what we can see, that this is a boiler having hemispherical roof, and here you can understand that one is grate. So, in the last class when we have discussed about Babcock-Wilcox boiler, we have seen that chain grate stocker. So, chain itself is acting like a grate. Grate is nothing but a plate, but which is perforated plate. So, the grate, if I write over here, the grate is a perforated plate. So, if we try to have a look at the top view of this particular component, it would be more clear to us. So, if we take a top view, the grate looks like this. So, this is the top view of the grate. So, this is the top view. Why it is like this? I mean, is it something that we had to fabricate this perforated plate? Yes, because when coal is taken over this plate, coal should be allowed to be in contact with the air, taking oxygen from the air which is supplied, rather which will be supplied, the combustion will be completed. So, only to make sure that sufficient amount of oxygen will be made available during the entire combustion process, the plate on which coal is taken for the combustion is perforated. So, the air will come from the small hole which is there in the plate. Okay. So, I hope you have understood the objective behind this perforation. Now, you know that so this is the grate. Now, entire combustion is completed, and 3 you can see this is ash pit. So, the entire combustion will be completed in the grate, and so this is the grate, and then this is the ash deposition. So, this is ash pit, 3 is the ash pit. Okay. 4 is firebox, that is shown. So, this is the firebox, and you know that the shape is like this, and this is the combustion chamber. So, entire combustion should be completed within this chamber, then the flue gas which is produced because of this combustion will be allowed to, rather will be directed to move towards the top of this device, and that is why this particular arrangement is there. The sole purpose is only to direct the hot flue gas towards the top of this device, and it will go through 4 and eventually it will move in the right direction through the pipes which are shown in 5. So, here we have, rather we can see there are 3 different tubes, and these 3 tubes are the fire tubes. So, depending on the requirement, the number of, I mean how many tubes will be there in a boiler is selected. Now, question is, while that flue gas is allowed to pass through the tube, and these tubes are surrounding the tube, there is a cell, and through cell water will be allowed to pass, and you have studied in heat transfer course that this is a kind of cell and tube heat exchanger. Now, while water is coming in contact with the pipe, and that pipe is having, so outer surface of the pipe is having high temperature, it is because of this heat exchange phenomenon water will be converted into steam. Question is that so this is a fire tube boiler, that we have written. Most importantly, you can understand that hot flue gas is passes through or is allowed to pass through the tube, fine, no issue, but what will happen? Water is passing through the cell. So, the amount of steam which is getting produced because of taking steam from the hot flue gas will be in equilibrium with the water that is there in the cell, and the consequence is that steam that we are going to get from this particular type of boiler is always wet steam. So, the steam which we are getting is the wet steam always in a Cochran boiler, but if we try to recall what we have discussed in the last class, that in a Babcock-Wilcox boiler, if we can somehow increase the length of the tube, we may get superheated steam. In such a case, it is not necessary that we should have separate arrangements like superheaters, that is convective superheater and radiative superheater. But in case of a Cochran boiler, it is very unlikely that we are going to get superheated steam, because steam which is getting produced will be in equilibrium with the water that is there in the cell, and as a result of which we will be getting always wet steam. So, this is one of the, I can say, one disadvantage of this particular type of boiler. Another important aspect is, let me discuss up here only. So, the tubes are there only to allow flue gas to flow, while water is taken through the cell. Now, steam which is getting produced, you know that by this time you have understood that boilers are a device which is operated at a high pressure. So, that means steam that we are going to get from the boiler will be having high pressure. If we need to have high pressure steam from a Cochran boiler, then the cell diameter will be very high, together with the thickness of the cell should be very high. If the cell needs to withstand that high pressure, diameter as well as its thickness will be very high. Now, if the thickness becomes very high and diameter is also very high, it is very difficult to accommodate such a larger cell as well as bulky cell in a boiler. So, it will invite another problem from the maintenance as well as initial installation point of view. Accounting for this particular issue, this Cochran boiler is typically used for an application where pressure should be restricted to 10 to 15 bar. So, this is very important. So, let me write here this Cochran boiler, rather Cochran boilers are suited. So, these boilers are suited for small pressure, say up to 10 to 15 bar. Why? Because I have already explained, since steam is produced in the cell and if cell should be able to withstand that high pressure of steam, what will be the consequence? The diameter as well as thickness of the cell will be very high. So, these two are the two different disadvantages of this particular type of boiler. Okay. So, now coming to the remaining components. So, these are the fire tubes, 6 is stack and chimney, because you can understand all these pipes are connected between two ends. In one end, that is 4, that is firebox through which flue gas is coming into the pipe, and other end of the pipe is connected to the chimney, I mean all pipes. So, ends of the ends are connected. So, outer ends are connected to the chimney, and that flue gas is taken through the chimney and it goes out, right. So, two things we have discussed till now. First of all, we cannot have, rather we cannot produce superheated steam using a Cochran boiler. Reason is, steam which is getting produced will be, rather is in equilibrium with the water. So, always steam that we are going to get from this boiler is wet steam. Second thing, since high temperature products of combustion, high temperature flue gas is allowed to pass through the tube while water is through the cell. To withstand that high pressure of steam, cell diameter as well as the thickness of the cell will be larger, system will be bulky, and it may not be always possible to accommodate such a bulky arrangement inside the boiler because of this space constraint, and as a result of which we need to restrict the application of these types of boiler typically to the pressure which is 10 to 15 bar. Okay. Next is water level indicator. This water level indicator, pressure gauge and safety valves. So, these three I have discussed in the previous class in the context of Babcock-Wilcox boiler. So, these three are basically I mean these are provided only to increase the safety of the boiler as well as its operator. So, someone will be there to operate the boiler, together with very important part is the safety of the boiler, because if pressure increases beyond a threshold value, all components will start malfunctioning, together with the cell will rupture. So, what I would like to say, considering the safety of the boiler as well as its operator, these components are integrated, like sorry, I have written this is not chimney. So, water level indicator, pressure gauge and safety valve. So, as I told you, the objective of placing an water level indicator is to always check the water level in the drum. If water level falls below that particular level, then it is a kind of indication the operator is getting, perhaps he or she needs to take special or preventive measure, because if water level falls, that means the entire space will be automatically occupied by the steam, and if the pipes which are already inner surface of the pipe as well as outer surface of the pipe is always at high temperature. So, if water level falls, you can understand the entire space will be occupied by the high temperature steam, and all components will be exposed to that high temperature steam, and that particular temperature may lead to the generation of thermal crack, and the components will start malfunctioning and the lifetime of the components will reduce. So, water level indicator is there only to indicate that okay, boiler the drum is having constant water level. Pressure gauge, because definitely you can understand, we know if this particular boiler is suited for 10 to 15 bar application. So, the pressure gauge will give us a reading that okay, this boiler is operating at a particular range. If it I mean you can understand. So, this particular water level indicator is an added safety that is provided. So, pressure gauge you can guess, if water level falls, pressure will automatically increase. So, that is an indication. So, these two things I mean these two components like pressure gauge and the water level indicator, these two are responsible to check the pressure inside the boiler. And safety valve, in any case 9 is given, because in any case that if water level falls, pressure will increase. So, that valve, the operator will be in a position to open the valve. So, to remove the steam from the boiler, essentially to save the boiler from the expected accident. Next is steam top valve. So, you can understand. So, this is basically steam space, let me write over here. So, this is steam space and this is water space. So, this is the water level. Now, we are getting steam being lighter than water, steam will be collected at the top of the water, and that collected steam will be taken to the turbine through this steam stop valve, right. Number 11 is feed check valve. So, 12 is the cell, you can understand this is boiler cell, and which I was talking about that if pressure increases in the boiler, that cell may rupture. So, this is not expected, I mean that is why this 7, 8 and 9, that is these three components are provided to increase the safety of the boiler, not only of the boiler as well as the operation of the boiler. Feed check valve. Feed check valve is that it is basically you can understand. So, this entire space is filled with water. So, that water is coming from a feed pump, feed water pump that you have seen basically from the condenser we collect the condensate, and that condensate is pumped back to the boiler. So, that is pumped back to the boiler using a feed water pump that we have studied. So, when that water is pumped to the boiler, this feed check valve is provided. The feed check valve is a one way valve. So, it allows only to water go into the boiler, but it does not allow that high temperature water will go back to the pump. So, this is a kind of one way valve. And number 13 is basically very important component, that is called fusible plug. So, you can understand, let me discuss about this particular component in the next slide, but what I would like to mention over here, that is not shown here, that is called refractory lining. So, this is refractory lining, this component. Say I am giving name 14. Refractory lining. See, basically that is provided. So, you can understand the high temperature products of combustion, flue gas is coming from the combustion phase to the firebox. So, this is the place through which high chances are there that heat will leak from the boiler. In fact, in the last class I have talked about the boiler efficiency. So, you can understand by burning coal, by burning fuel, whether it is a coal fired boiler or diesel fired boiler, we are providing energy to the boiler. At the cost of that input energy, we are going to get some amount of change in enthalpy of the working substance, and water will be converted into steam. Now, in the process, if sufficient preventive measures are not taken, what will happen, that heat which is coming out from the combustion product, that heat will leak from the boiler surface, and that is why this surface, this lining is given, so that this surface, this this particular layer acts like a insulator. So, it does not allow heat to go out from the boiler. So, this is refractory lining. Now, let us briefly discuss about, there are two different cycles. One is what we can understand, hot flue gas cycle. So, if we write in the next slide, water steam cycle, and number 2 is hot flue gas cycle. So, this is basically very important to understand, because understand the flow path of these two cycles, two different streams. Hot flue gas is, if we go back to the previous slide, it is coming from combustion space to the firebox, goes through the fire tubes and ultimately come out through the chimney to the surroundings. So, this is 2, 4, 5 and 6, that is the hot flue gas cycle, 2, 4, 5, 6, right. What about water steam cycle? You know that here we can see, we have seen that this entire space is filled with water, and that when that I mean this is this water is coming from this feed water line, and the water is allowed to pass through the cell, and the steam which is getting produced is collected at the top of the water surface. So, basically water cycle is very difficult to, or what does water stream, water is in the cell, steam is produced, that steam is collected at the top, and finally that steam goes into the turbine through steam top valve. So, I can write that basically 11, so that is 11, then if I give name of this particular, say this is 15, and then this is 16 steam space, 15 is water space and 16 is steam space. So, basically 11, 15, 16, 10, 11, 15, 16, 10. So, this is this steam water steam cycle. So, this is not only the water cycle, because initially up to 15 it is remaining water, but when it is coming to 16 it is a steam. So, this is what water steam cycle. Okay. Now, let me briefly discuss about the fusible plug. So, if we go to the previous slide and we understand that fusible plug is basically why it is provided. So, this is the fusible plug, this particular component. If we draw it in the next slide, so I am writing. So, this is fusible plug. From the name itself you can you can guess that it will fuse. What will fuse? So, the fusible plug is given like this. Let me draw that fusible material using another color. So, this is the fusible material, right. So, let me discuss what will happen. Say water level indicator is not functioning properly. So, it is very difficult to understand by an operator what is happening inside the boiler. If water level indicator is not is not working perfectly well, and if water level falls because of any reason, what will happen? What will happen? That steam which is collected at the top will try to occupy the space, that is 15 water space. So, when the steam is occupying the water space even because of the reduction of the water level inside the boiler, it may be because of any reason, maybe water that feed check feed water line is not working properly. So, as I told you that it is not advisable that all these components will be exposed to high temperature steam. If it is the case, then at that high temperature there is a possibility of having the thermal crack in the components, and that is not that is very detrimental for the boiler operation as well as boiler safety point of view. And if water level falls and it goes below up to 13, then this particular plug which is there. So, this particular plug, so this this component will be at the it will be in contact with the high temperature steam. The material which is welded, so this plug is welded with this this wall with a material, and that material has low melting point temperature. So, when that particular component is in contact with high temperature steam, that material will melt and this plug will drop. If the plug drops, as if it is creating an opening for steam to go into the combustion chamber. So, if we go back to the slide, what will happen? So, water level is reduced, steam has occupied the water space, this particular component is now in contact with the high temperature steam. Because this component is melded with this particular component is welded with this wall using a low melting point temperature material, that material will melt and this plug will drop, and when the plug drops we are getting an opening, and through that opening what will happen? Steam will occupy the combustion chamber and the steam will try to arrest the further combustion that is going to happen. So, if the combustion can be arrested when steam is coming through this particular opening and it will occupy the combustion space, combustion will stop. If combustion stops, then perhaps boiler can be saved from a undesirable accident, and the function of this fusible plug is to again provide additional safety to the boiler operation. So, to summarize today's class, what we have discussed about the operation of the Cochran boiler. We have tried to find out the disadvantageous feature of this particular boiler in the context of the steam power cycle. Then we have discussed the objectives of all the components which are there in this particular type of boiler. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.